for joining us for this morning's SPEAR Speakers Bureau webinar. SPEAR is a nonprofit that works to advance energy efficiency in Texas and Oklahoma. Our Energy Codes program promotes compliance with state energy codes through training, outreach, and peer support. As part of that effort, we bring you Energy Codes webinar sessions like this one every month. Today, we'll be having Tim Prevost with High Velocity, and he will be presenting on HVAC equipment solutions for energy efficient homes. A few notes about how this webinar will work. Most of you guys already know this, but all attendees are muted. And if you have a question, you can just fill it out in the Q&A box at the bottom, and Tim will answer them towards the end of the webinar. These webinars are all ICC certified, so if you are watching today, I will issue certificates. I'll send out a survey following the webinar, and if you indicate that you will be needing an ICC CEU certificate, I'll send it your way. And with that said, I will have Tim introduce himself and get started.
Thank you, Marielle. I appreciate it. My name is Tim Prevost. My company's name is Energy Saving Products, and we've been manufacturing fan coils for almost 40 years out of Edmonton, Alberta, Canada, and we sell our energy efficient products into every continent worldwide. Our predominant product line is our small duct high velocity solution, which provides our customers with numerous advantages on installation, but also the homeowners a level of comfort that is regularly not achievable with traditional forced air. And I'm going to explain how a high velocity system can be installed easier, but also provide those better levels of comfort, specifically in low load homes. Low load homes have a whole host of issues that can arise without proper mechanical equipment selection. Oversizing is a very regular occurrence and can create issues down the line with mold in homes and uncomfortable settings and comfort levels for the occupants. And I'll show you how we have a great solution for low load homes by specifically being able to match the exact load of the home with our fan coil products. Now, first off, I'm going to talk about what a high velocity system is, and a lot of it revolves around the ducting. But to kind of understand that, a quick brief explanation on what low velocity versus high velocity means in the ducting world and the duct design world. Conventional forced air, pressure is converted to velocity right at the fan cabinet. We design on traditionally 0.1 to 0.5 inches of static pressure, which is called low velocity. It requires a proper duct design, a squeezing of the air in order to try and ensure adequate airflow at the end of the line versus what you're going to see at the beginning of the line. We have to add balancing dampers to ductwork, and we have to virtually trick that airflow to get to the furthest outlets in that home, often requiring at times things like booster fans, balancing dampers. At the termination point, when the airflow enters the room, it uses the throw-in diffusion method of air delivery, trying to divert that airflow in multiple directions in the hopes that by doing so, you're going to create a stirring of the room air and mix those heated and cooled BTUs throughout that space. We also manufacture conventional forced air products, and we do a lot of testing on product A versus B. With conventional forced air in the traditional airflow method, lazy air is a prevalent factor. Hot air rising, cold air dropping, and the stratification of that air is something that exists in most residential and commercial structures. We have to put ceiling fans on vaulted ceilings to try to get the heat off of the upper echelon of the space during winter, and to try to mix those BTUs that are being created from our gas furnace production or whatever heating, cooling system we're utilizing. With a high velocity system, we operate around 1 inch of static pressure, and we maintain that pressure throughout the entire duct system without duct reductions. without tricking that airflow to the end of the line. When we turn on our fan, it pressurizes at the end cap back to the fan coil with an equal consistent static pressure, which gives us numerous advantages on where we can run ductwork and how long we can run ductwork versus traditional duct systems. With that equal static pressure, it gives us equal airflow to all of the outlets on our high velocity duct system. It's a self-balancing system. The balancing is done during the duct design, which is a free of charge service offered at our factory. Now, the real magic of what happens with a high velocity system is at the termination point, when we convert that pressurized airflow to velocity entering the space, creating the Venturi effect. As that airflow exits out of a high velocity outlet, it is going to draw in the regularly stagnant room air all around it and force a total mixing of the room air. So as that air is coming out at about 1,200 feet per minute, it creates a low pressure zone 360 degrees around that outlet. That low pressure zone is going to grab that still stagnant room air and pull it into its airstream, forcing total circulation from floor to ceiling. Even with the absence of a return air in a room, we will mix and move that entire room air, where with conventional forced air, you spill it out of one side of the room and have a return air on the other side of the room in the hopes that that draw from the return will be forcing that mixed heated cooled BTUs to the space. Because of how we're mixing and moving air, no matter where we locate our outlets, in the ceiling, in the floor, or in the wall, we are going to get a total mix of that room air, giving us temperature, even temperature from floor to ceiling throughout these structures. In a high velocity conditioned home, you can put a thermometer on the ceiling, a thermometer on the floor, and see less than a degree of difference. And this really excels in vaulted ceiling type of applications. Now, because of how we're mixing and moving air, we have flexibility with where we locate our vents. We don't need to put them all to the outside walls and by the windows. No matter where we locate outlets, we're going to mix and move that air properly. We're going to be putting outlets in floors, and our criteria is a little bit different than traditional, where we want to put it by windows and doors. We're aiming for low traffic areas. We're aiming for parts of the home that are not going to get covered by furniture, and we're going to have an uninterrupted airflow to allow that high velocity duct and air movement to do its thing and mix and move properly within the space. High sidewall is also a very popular application when we're dealing with exotic floors, crown molding, and architecture. The high sidewall application, when we're trying to eliminate bulkheads and soffits from structures, is utilized quite regularly, especially in the high-end residential market, as we're showing in some of these pictures right now, where I got some nice before and after shots, just simply taken from my iPhone here on some high-end homes. In kitchens, underneath in the kick plate was always a traditional location. We always try to look above that kitchen cabinetry where there regularly is some void to locate high sidewall delivery outlets. In ceilings as well, there are times we're going to be installing this stuff in attic spaces or in ceiling spaces, and locating those high velocity ducts symmetrically with the pot lights in the structure to try to maintain good cosmetics within these high-end architectural developments that we often are a part of because of our small duct solution. Ultimately, anywhere you locate these outlets, you're going to get the proper mixing and moving of the room air that you require. We have different styles of finishes available on our round high velocity outlets. The oak and the maple come unfinished, so you can stain and recess them into hardwood flooring, which is a very popular option. But the white plastic is what comes with every unit out of the box, and can be replaced anytime after the fact. When our customers buy the flexible duct package from us, it comes with everything that you require for the entire installation, from the takeoff connection to your metal duct, to the boot, 90-degree rough-in boot, which has a 100% shut-off capability. Again, it comes with the white plastic outlet in the box standard, but we do a lot of different options, and even some of our customers like to go with a traditional grill option, of which we do have options available as well for straight line architecture within structures. Our airflow is delivered through our patented high velocity flexible ductwork. Our flexible ductwork we sell in 5, 10, 15, and 25 foot lengths. We would traditionally tell our customers that we need to run a full 5 feet of flexible duct to allow the acoustic properties of that ductwork to do its job to make these quiet, silent operating systems. We do sell the flexible ductwork in both R4 and R8 insulation values, depending on what jurisdictional requirement there is, and depending if we would traditionally use the R4 in conditioned space and the R8 duct in unconditioned spaces. The main plenum that's going to be coming off of the air handler, we would start off with either a 6-inch, 8-inch, or 10-inch diameter main metal plenum duct, of which we would suggest to be insulated. And that main plenum duct, the sizing will depend on the load requirement of the home and the size of the equipment that you will be installing. That round duct, 6-inch, 8-inch, and 10-inch, can be converted to a low-profile rectangular or oval ductwork if you have restrictions throughout your structure that you're trying to pass through and the round duct does not fit. You can pull out a ductulator and find an equivalent duct size to what you're dealing with, and then you're off to the races. Now, because of that pressurized plenum duct at that higher static pressure, we don't have to locate the mechanical equipment as a central air handling system, which was dictated due to the fact that we wanted to keep our duct designs down to a minimum on our installations and prevent starvation of airflow further down that line. We're going to ensure adequate airflow no matter how long our plenum length is and where we locate it. By doing so, we can locate our equipment now in the more unused locations of the home. If there's a small closet in the corner, instead of taking up that central expensive square footage in most of our structures. When it comes to return air, we still need return air duct, but because our system's not reliant on the return air to mix and move, we do not require return air in every single room throughout the home. Most of the contractors that are our customers will elect to go with a central return air per floor, which is more than adequate to get the energy back to the air handler it requires to create the heated, cooled BTUs at the power plant and deliver them throughout that space. You can put return air in every single room with a high velocity system, although it is not required. The central return air is most commonly practiced, and we would insist on some sort of a 1/2-inch undercut under most doors for airflow to escape out of a room if that door does close. Now, when it comes to the energy efficient homes, the new load calculation certifications, we're finding trends in the industry where residential structures are often below 30,000 BTUs of space heating requirements and below 2 tons of cooling requirement in structures that would traditionally go with 70 to 80,000 BTUs and 3 to 3.5 tons of cooling. When these structures are built considerably more efficient with insulated windows, oversizing products into these homes can create a host of issues in the comfort level of the occupants, whether it's clammy feeling from short-cycled air conditioning equipment, or whether it's dry air, scorched air from an oversized furnace in a structure that requires 1/3 or less of what is being produced from the power plant. Issues like this arise on the regular with low-load homes. I'm speaking a little bit from a Canadian perspective, where we are dealing with very energy efficient conscious builders. One of these, there's an example on the sheet that you're looking at right now. We've been a part of a program traveling across Canada, putting on our equipment selections and showing builders across the country what can be done in these situations. And I'm happy to share that with you right now. So taking a look at the design load for this specific home, 23,000 BTUs of heating and 16,000, 1.4 tons of cooling requirement on this 3-story home. What are you going to select for equipment? I left this slide in this presentation so that if you would like to take a look at the slide deck after the fact, we'll be providing that to you through a download. And this has a really good options which talk about design challenges in these low-load homes and solutions for these design challenges. I won't read through all of these, but I left the slide in the slide deck so that you could take a look at it after the fact. But the solution that I'm going to talk about right now for this low-load home tackles all of these HVAC options and challenges through our small duct high velocity solution. Right off the bat, being a fan coil, we can specifically select the BTU output based on water temperature if we elect to use hot water heating, which is in the northern US and Canada, the most popular option to go. Down in southern US, heat pump is certainly the most popular way of heating most structures. But this HEZ 50 fan coil system, which I'm showing the spec on right now, is going to start off with an 8-inch duct and branch off into 10 of our 3-inch flexible ducts throughout that space. The unit can be installed traditional upflow, horizontal, or downflow, depending on the mechanical configuration available to us. It's designed for 1.5 to 2 tons, so we can put a 1.5 ton to meet the 1.4 ton load. If that outdoor unit is a heat pump, it will easily produce the 26 to 23,000 BTUs required for that space. Or going with a hydronic solution, we see that the entering water temperature of 120 degrees Fahrenheit gives us 25,000 BTUs of heating, which is more than enough to meet the heating requirement for the structure in question. We would likely, knowing that I'm talking into a Texas market, I believe we would be doing a lot of heat pump in that application. Our coils are all heat pump ready out of the box and ready to be installed with any third-party heat pump manufacturer. What I'm showing here is our coil location, which is non-traditional, being on the return side of the blower cabinet. Being a return side cooling coil, we can get considerably more latent cooling, and that's considerably more humidity removal and moisture removal from the air. In high humidity locations, cooling just the sensible temperature of air can lead to clammy conditions within a home. Having properly sized air conditioning equipment will also remove the latent content, the moisture content from the air within the structures, providing a much more comfortable feeling to the occupant. We have a lot of feedback from customers that say, I used to have to set my thermostat to 68 to be comfortable, but with the high velocity system, I can set it to 74 and be just as, if not more comfortable than my old system. And why is that, they ask me? It's simply because of the extra latent and moisture removal from where we locate the coils on our installations. Now, when we talk about heat pumps, in most northern climates, a heat pump isn't going to be able to heat 100% throughout the year, and there needs to be some sort of backup auxiliary heat source. We do have multiple options for that, one being an electric strip for electric resistance heat that slides into the air handler, basically creating an electric furnace that is available in fixed, also modulating panels from 5 to 25 kilowatts. Most of what we elect to do, because of the proven efficiency, is hydronic hot water heating as either primary or auxiliary backup heat source. In all of our products, we have a 6-row water coil, which gives us considerably better BTU output at lower entering water temperatures. That 6-row coil slides into the air handler, and it can be connected up to any water source. What we see most of in our market up here is a tankless type of technology like a Navien, Takagi, Rinnai type of water heater. And that technology has been proven to get better and better, and even working up in our cold Canadian -40 climates for heating. So a tank versus a tankless provides a ton of efficiencies on the tankless side by not having stored water heating and cooling all day with or without usage. This is a very typical system schematic that we're utilizing on these low load type of homes. And another very integral component is adding the HRV or ERV off of the fresh air solution to give that home a fresh air solution that is not only going to provide the right levels of oxygen throughout the home, but also give a cleaner, more comfortable condition through the HRV, ERV technology. That installation can look something like this, although I've seen this equipment stuffed into very tiny closets as well, which is often what is available to us in the multifamily type of world and installation. If looking for other efficient power plant options in the HVAC world, geothermal is an option that is available, where you can just use the high velocity system as the delivery source. And because of our efficient 6-row water coils, we excel in the geothermal world, where we have lower water temperatures available to us in heating and higher water temperatures available to us in cooling from traditional other sources. I am also a big fan of solar production. Personally, I feel like solar has proven to be the most efficient renewable available to us right now. And we have a fantastic net zero option where we've been doing net zero communities across North America, utilizing solar production and our heat pump option for heating and cooling. That home that we've seen the 23,000 BTU, 1.4 tons of cooling load is shown in the design that I've got here right now. Something that we also offered on this duct design was a zoned system. We didn't just put in one thermostat for the one mechanical unit. We offer a thermostat per floor. We can zone our small duct high velocity extremely simple. And we try to make it the most efficient zoning package out there by eliminating the requirement for dump zones and bypasses. If you have any further questions on how we're making that zoning work, by all means ask, and we've got some time at the end of this that we can go through the zoning criteria. But having that thermostat per floor also provides numerous efficiencies rather than running the equipment at 100% all the time to meet a small demand. We can operate at 1/3 or less, depending on how we're designing that zoned duct system. We even fit our equipment at the factory with dampers and zone controls to make it simple and easy in the field for our customers to install these systems. So it comes with the damper and zone control. You run an independent duct to each area, and off of that independent duct, one thermostat will provide the demand to turn on and turn off the system based on the occupant's requirements. When it comes to zoning air handlers, we strongly recommend more efficient, better technology than the traditional low SEER fixed speed. So we suggest 2-stage condensers on up to 3 zones. And if you're going past 3 zones on a single air handler, we look at chilled water or something like our manufactured inverter drive heat pump. We have our own inverter drive heat pump into the marketplace. It says here 3-ton and 5-ton cooling capacity. We now have a 2-ton product available. It's rated down to -30 Fahrenheit for heating operation, which allows us to present this as a net zero option in the markets that are doing net zero styles of installations. The government of Canada actually has a mandate that by 2030, all new homes will have to be net zero ready, only missing the solar roof component to making it a net zero home. These heat pumps being rated down to that low temperature are going to be a utilized solution for that in many applications. And the type of applications that specifically we talk about the most is these multifamily row housing or small condominium walk-ups, 4 to 6 levels. We've been part of a study of how do we introduce net zero energy into these low load areas, but also how do we do it cost effectively? Sure, you can just throw money at these jobs and have the right solution, but having a cost effective solution is another thing, which we have been able to provide with our high velocity package, our low temperature heat pump, and most often an electric backup heater for electric only projects, or a gas hot water heater as the hydronic backup solution. In these type of facilities with our smaller duct, we can get the installation to be almost cookie cutter, where guys are installing 7 plexes in 2 days because of how simple and easy the ducting solution becomes on these sites. All of our air handlers are multi-positional out of the box, upflow, downflow, horizontal. They're available in 110 volt or 220 volt applications. We offer a 5-year parts and labor warranty, and we're offering a 10-year extended warranty for a small cost. What sets these air handlers apart in the energy efficiency conversation is what we're doing inside of them. We're not using the standard ECM motor, which is believed to be one of the most efficient options in the industry. We're using something totally different. We're using a variable frequency drive motor and control. The variable frequency drive gives us infinite variability with the airflow settings on our air handler. We have dials to control the air speeds up and down and set speeds independent. We can set our cooling speed up at 100%, the heating speed set anywhere from 70 to 80%, And then we always talk about running constant fan operation with these fan coils because of the energy efficiency that can be provided with running constant fan, but also the added indoor air quality benefits that can be achieved in structures by running constant fan with better, denser filter media. When we switched to our variable frequency drive, the energy usage requirements dropped dramatically from the traditional motor style. But the number that I really like to talk about is that low constant fan number operating around 60 watts of energy to operate constant fan in your home. And if you talk to the end users about running constant fan in your home because of all the indoor air quality and oxygen benefits that can be achieved, they're going to say, why would I run my fan? That's going to cost me money. And with traditional systems operating at 300, 400 watts on low, they're not wrong. But a system like this, operating on 60 watts, the energy of a single light bulb, it can be more influenced to operate these benefits and to get the indoor air quality benefits that can be achieved, as well as efficiency benefits. So on our circuit board, we have literal speed dials to adjust these airflows to meet the comfort requirements. But also when it comes to the conversation of that constant fan, we can set the speed at such a low per that the homeowner occupant doesn't even realize it's on and doesn't even realize that they're getting the indoor air quality benefits of that constant fan and the energy efficiency benefits. Now, where are the energy efficiency benefits of running constant fan? Your thermostat on the wall, if you think about it, it's just a device that says, I'm cold, make me hot, or I'm hot, make me cold. When that thermostat becomes unsatisfied, it turns on all the equipment and starts the party. Everything starts moving through the home. As soon as that thermostat becomes satisfied, it stops the party. When you stop airflow, stratification of air will occur. Hot air rises, cold air drops. It's not long before that stratification reaches a level that the thermostat becomes unsatisfied and starts again. We have had independent tests done that show by running constant fan, by destratifying the air, you keep the thermostat satisfied longer. By keeping the thermostat satisfied longer, your main energy consumers, your hot water production, your outdoor air conditioner running at 1,000 watts, those items run less and can provide major energy savings. This was an independent test done by Natural Gas Technologies in Quebec that tested our equipment on intermittent fan during heating cooling production versus running constant fan on a low fan speed between heating and cooling calls. And it showed an average of 20% energy savings by running constant fan, which is that 60 watts of energy, that light bulb's worth of energy on the low fan speed, and keeping the thermostat satisfied longer by doing so, on top of the indoor air quality benefits. Now you're talking about a system that's going to run its fan 24/7, and that filter that you put on your fan, your furnace, your fan coil can actually do its job 24/7 instead of running for 5 or 10 minutes out of the hour maximum. Now you can be influenced to put something more consequential into your filter system, whether it's a MERV 13 style of filter or something like an air purification system that tackles all three classes of indoor air quality. Running constant fan with an air purification system like our high velocity one shown in the diagram now can provide you with hospital grade levels of indoor air quality into your structure. Our answer to date on indoor air contamination is dilution. We're going to dilute contaminants by bringing fresh air into the home to dilute those contaminants. And maybe with an HRV, we might exhaust some of those contaminants out of the home as well. Diluting those contaminants doesn't eradicate them from the home, but running constant fan through your air purification system or denser filter media, that is what is going to now treat the air within your home instead of diluting it with just the fresh air capabilities. This product here is a MERV 13 filter, 2 UVC germicidal lamps that deactivate and destroy microorganisms and viruses, and then 56 square feet of a patented titanium dioxide catalyst, which eradicates gaseous compounds, the off-gassing of glues in your hardwood processes into your home, the off-gassing of paints on your walls, and the PVCs and the furnishings and the kitchen accessories. All of these off-gas harmful chemicals into the air that we breathe every day. And this is a product that is proved to take those out of the air. Combining that with the way that high velocity mixes and moves air better can give you unparalleled levels of indoor air quality to your structure. With that, I will end my presentation. I greatly appreciate everyone who came on and attended this today. We still have 20 minutes available where if we have any questions, I would be happy to go through them with you as well. I believe that we are going to be providing you with my contact information. So if you wanted to continue the conversation at any time one-on-one, we would be happy to do so. We will also be providing you with the slide deck if you wanted to review it at any point in time.
Hi, Tim. We do have a few questions on here. That was really great. Thank you. So the first question is, how does the cost compare to conventional systems?
Great question. If it's a one-off installation, we typically material to material would come out 10 to 20% more in material to material. And what a lot of that is my pre-insulated flexible duct is more expensive than 4, 5, and 6-inch tin that you would be using on traditional duct work. The equipment itself is pretty close. When we get into projects that we're doing multifamily and multiple units on a site, we do get very aggressive with our pricing to meet exact costs of what your traditional installation, be it a Goodman furnace or a train heat pump. We get really close to that number so that we can get those larger projects.
Great. And just a reminder to everyone on the webinar that there is the Q&A box at the bottom of your screen that you can feel free to type in, and I can relay these questions. But we do have a few more. This one relates to sound. How does the sound compare since high velocity is generally audible?
Great question, and it's a question that we have to answer on a daily basis with our high velocity systems and kind of the trend throughout the years on some of our competitive products being a louder system. We're using a 3-inch flexible duct, which makes a big difference in sound level from the traditional high velocity 2-inch ducts. We also are the only high velocity manufacturer that actually manufactures our own flexible duct. And we do it to the highest quality standards that are designed to give it an acoustic property that makes our airflow delivery on par, if not quieter, than conventional systems. We have got a lot of feedback and we have sound data available that show our operating sound is on par with conventional, if not quieter, depending on how we design and install these systems and how many outlets we put into that installation. Great question, something we have to answer on a daily basis. And if you are interested, we do have installations throughout Texas as well that we likely can open the doors to some people to have a look at some point in time. Sometimes it takes touching, feeling, and seeing this stuff to believe it. So we have to have show homes all over the country to allow people to experience that.
Great. And we have another question. I know that you had mentioned humidity a bit earlier on, but how does the system work in extreme humidity climates like Houston, where the average humidity is around 90% and summer temperatures can reach over 100 degrees?
Yes, so traditional systems don't really focus on the latent cooling, which is moisture humidity removal. Where we locate the coils on the return side of our air handlers, it means that it's a lower velocity across that coil. Traditional systems will put their AC coil on top of their blower and blow into it, which is at a higher velocity across the surface area of that coil. With our coils being a lower velocity across the coil, it has more contact with the surface area of the coil, and it drops the temperature almost double of a traditional air system, almost 30-degree temperature difference, temperature drop in AC. And that extra contact with the coil removes a considerably larger amount of moisture just in regular AC operation. Knowing in places like Houston, Florida, the UK, Shanghai, China, or Northeast Australia, where humidity is just at an astronomical level compared to most of the other world, we also have a dehumidification cycle built into our circuit board. So with a humidistat sensing humidity in the home, if the humidity level rises above the set point, we operate our dehumidification cycle, which is low fan speed cooling operation, not designed to lower the temperature of the home, but just specifically designed to remove the humidity out of the structure and create that more comfortable environment with lower moisture content through the home. So we've thought long and hard about how do we utilize that extra latent cooling on our products, and it's with a dehumidification cycle that trumps an air conditioning cycle as well. So it's a very popular use on coastal markets and high humidity areas. Hopefully it wasn't too much of a science-y explanation, but I tend to get that way sometimes.
No, that's awesome. So we do have another question. So how can this unit be utilized in an Energy Star house since excessive length and coiled duct runs are prohibited?
The duct runs, if properly designed, do not need to have the coiled flexible duct. We would prefer to design the duct system to an engineered level where all of our lengths meet the minimum of 5 feet length, and they do not need to be coiled. Now, how can we use an Energy Star project in the US? I'm becoming more familiar with that process, as in Canada, we are able to be used in Energy Star projects because of an efficiency standard similar to air conditioning SEER requirements in the US. In Canada, we have an efficiency standard for heating. And when pairing us up with a tankless water heater, these governing bodies are able to put an efficiency number on our products. And if we need a certain level, we're able to be used in Energy Star projects. Now, translating that to the US Energy Star program is something we're navigating right now, but we are utilizing Energy Star projects throughout Canada, and we're working with the US body of Energy Star to make that happen with us as well.
Great, thank you. So how does the system work in a 100% sealed spray foamed home?
Great question. I have a builder in my hometown of Edmonton where we do 1,000 homes a year, and they own their own spray foam facility and trucks. and they spray foam every home. That is the topic in question right now. When you spray foam a home 100%, not only does it become 100% sealed, but your load requirements drop dramatically. And how do you find a system that's only going to produce 17,000 BTUs of heating, 1 ton of cooling, but still meet the ventilation requirement of the home just to keep it fresh and the CO2 level to an economical level? Well, there's a fine line between that, installing a ducted air system and keeping the loads low as well. Spray foam is a great technology on making tighter, more efficient homes, but it creates these low load mechanical issues, of which we feel like we have a great solution for that. Now, in my home, which is a spray foam home, new construction I bought about 7 years ago with our high velocity. I tried running a couple of years without air conditioning, which might sound crazy in Texas, but it's not so crazy up in Canada to not run air conditioning in a home. And I noticed with the spray foam, in the middle of summer, it might only be 70 or 80 degrees outside, but it would jump to 90 plus inside the home with that spray foam retaining any heat from internal loads, from the fridge, from the washer dryer, from the computer room, all producing heat within the home that would take the temperature right up. It was 2 summers before we figured out that we needed air conditioning to really be comfortable in our space. So that spray foam will retain any heat within that structure, which actually accentuates the air conditioning call. So taking into account internal loads on air conditioning requirements for low load homes is a critical factor that we've encountered when designing these systems properly, is taking a look at what we're doing in that structure and adding internal loads as well. Hopefully that answers that question about spray foam.
Fantastic. So the next question is, what is the availability of repair parts for the system in Texas?
We actually have a warehouse in Dallas, Texas that ships our products all across the southern United States. So we do have product factory warehouse in Dallas that we utilize for the southern US. So parts are readily available.
Great, good to hear. Next question, how important is duct sealing when with the high velocity system, and how does, go ahead.
No,
there was a follow-up
finish the question,
but we can get to that in a sec.
Okay, sure, yeah. So I didn't really get into it, but the duct sealing is critical. It's something that we've been talking about for the entire existence of this company. So to some contractors, duct sealing is new. For our mature contractors, it's regular operation, everyday operation. With a high static duct system, if there's a place for that air to leak, it's gonna find it, it's gonna potentially whistle, and it's gonna create an issue within your structure. So duct sealing, absolutely critical with a high velocity duct system. Painting the elbows, the T's, and every connection point with high velocity mastic paint sealer, or using metallized foil duct tape are both approved ways of sealing our ducts. That being said, our customers tell us it's considerably easier to seal 6-inch, 8-inch, and 10-inch round duct than it is to do traditional metal rectangular duct work with multiple seals. So that's some feedback we've gotten back on sealing. It is a critical factor though. Go ahead with the follow-up, Mario.
So the follow-up was, how does the amount of air leaking at high velocity compare to the measured leakage at 25 PA?
I don't know the exact math on that, but we provide 100% sealed duct systems so long as the plenum is sealed. The flexible duct component provides a gasketed seal that's a 100% seal with the absence of extra sealant, but the metallized plenum duct is. I can tell you in the states, such as California, where they've adopted really intense regulations on HERS rating requirements for mechanical in structures, as well as blower door testing of the homes and duct leakage tests. Our contractors always pass with flying colors on our high velocity duct system. I can't think of a contractor to date that has failed the duct leakage tests that are required in states like California and Massachusetts that have a very high energy conscience requirements for their installations.
Okay, another question popped up. I'm not sure if this was covered earlier, but what is the typical design friction rate on systems like this system?
We would typically design these at 1 inch of static pressure is how we like to design our high velocity products. 1 inch of static pressure is lower than other traditional high velocity manufacturers, but that's what we've found to be the optimal for energy efficiency and noise control with our product line. That being said, anybody interested in taking a look at how these systems can be designed into your structures can contact us. Our factory provides a free of charge energy calculation and duct design drawing for all of our customers.
Great. That was fantastic. So if there are any more questions, you can feel free to send them over to me now. We don't have any more in the queue. If you wanted to share any final thoughts, Tim, go ahead. Otherwise, we can wrap up.
Yeah, I commend any builder developer company that is looking at building these homes more efficient. And one of the big issues that will prevent builders from doing so is just prohibitive costs. And as the products for these high-end homes are becoming more prevalently used, those costs will go down. We're seeing code dictate a lot of this up here in Canada, in places like California. I've heard that Texas has quite an energy efficient contingent as well here, and we're happy to work with anybody that is open to looking at non-traditional solutions for their mechanical systems. So we're an available resource for anybody that has questions regarding mechanical selection. Whether you're using our products or not, we just like to see the industry become more educated in this regard, and we're happy to be involved in that in any way, shape, or form. So we really appreciate you tuning in today, and thank you for your time.
Awesome, thank you. We really appreciate your presentation. To all of the attendees that are still on, I will be sending out the course evaluation likely later this afternoon. So if you would like an ICAC certificate for attending this webinar, please indicate so. And our next webinar will be early next month. Thank you so much, Tim, and thank you for joining us. I will send out Tim's contact information in my follow-up as well. And looking forward. Thank you so much.
Thank you. Thank you.
Bye-bye.